What's poppin', dogs? Mr. Allen here with a couple circle problems in this video. We got in circle E, AC is 12, so this chord right here is 12. ED, which is this guy right here, is 8. What is the area and the circumference of circle E? So AC is a chord, right? EB would be a radius, and then all the way across the circle and through the center would be a diameter, right? So any other segment that's drawn in a circle from like edge to edge of the circle, that's called a chord, okay? Now, here's the cool thing. When a radius is perpendicular to a chord, it also bisects that chord. So we get two congruent segments. The same goes the other way. If it's bisected, then I'd get perpendicularity or a right angle. Now, if we label this thing, we got AC is 12, but why don't I label this as 6 and 6? And I got ED is 8, and I want to find the area and the circumference. So what do I need if I want to find the area and the circumference? Well, my area formula, area is equal to pi times my radius squared. And oftentimes when I'm doing area of a circle, I even draw like a little circle down here, right? To notate that we're finding the area of a circle, not like a square or a triangle or whatever, okay? I usually throw the shape there with that area, the big capital A for area. Next, we got circumference, right? In circumference, I have two formulas, but my favorite would be 2 pi r, right? If I'm going to choose one, I'm usually going with that because a lot of times I can work with the radius for the circumference, or I can do it for the area. So more universal, I guess. Now, I don't have a radius, right? ED is not a radius. EB, that entire thing is. How can I figure that out? Well, all radii in a circle are congruent. What if I were to draw in another radius? I'm going to use this ruler here that I have from, this is like from like 4th grade, okay? It says, James Allen, what's up? With an exclamation point. My parents found it in their basement, and then now I use it here to make videos, right? So, big throwback. Let's draw in a radius here. Boom. All right. And what's that radius going to be? Well, this is 6. That's 8. We do have a right triangle here. This is perpendicular, right? That's going to be 10. How did I know that so quickly? Well, I remember my Pythagorean triples, and this is a 3, 4, 5 Pythagorean triple. 3 squared plus 4 squared equals 5 squared. That's been doubled to 6, 8, and 10. If you didn't know that, it's okay. You can always do 6 squared plus 8 squared equals c squared, or my radius squared, and I can solve it. I'd have 100 equals r squared, square root both sides, and I get r equals 10. So either way you slice it, I'm going to get 10 for my radius there, which is wonderful because now I can find the area and the circumference of the circle pretty easily, right? We'll pop in a different marker. We'll go blue with this one. So the area of the circle, area of this circle here is going to be pi times my radius of 10 squared, which I know is 100 pi. We don't have any units, so we'll say units squared. So there's my area. Lovely. All right. Next up, we got circumference. I'll go with orange on this one, okay? So circumference, we've got 2 times pi times my radius of 10. So we're going to get ourselves 20 pi units. Boom. Nice. All right. Now, this is what's called in terms of pi. Okay, if I wanted to put this in decimal form, I got my calculator over here. It's not hooked up to the fancy emulator, but either way, I can do 100 times pi, so it's going to be like, what, 314? But, you know, I'll type it in anyways. We'll get all the decimals. I don't know why I'm actually typing it in. I know what it is. Okay. Anywho, so my decimal equivalent here, and I'll put it down here where I have some room. Area of this circle in decimal is 314, 3.14159, so 16. I did get it right. Okay, cool. And again, that's units squared. So that would be our decimal equivalent, hence the little squiggly equals there. It's an approximation at this point. And then my circumference, that decimal would be, well, 20 pi. I could probably figure it out, but I'm going to go ahead and just multiply it. 62.831, so 62.83 units. So depending what your teacher wants, usually we keep them in terms of pi. With circles, they're a little easier to work with. You get nice integers most times. A lot of these problems are going to involve Pythagorean triples, which makes the numbers easy to work with. Keep it in terms of pi, good to go. Okay? So that's my favorite, is keeping it in terms of pi. I just work with all the numbers, right? That's like your mathematical meal, if you will. And then the pi is your dessert. Save it till the end. There we go. Anywho, let's go over to the other one here. So now I've got the area of circle A is 625 pi inches squared. We do have units on this one. And dB, this entire thing is 48. Looks like they are congruent. Why don't I just label that right off the bat? This is going to be what, 24 inches and 24 inches. Find CE. Well, what can I get from the area? I can get my radius, right? So we got area of the circle equals pi times my radius squared. I know that I have 625, right? 625 pi equals pi r squared. If I divide by pi on both sides, those cancel. I have r squared, I'll come over here, r squared equals 625. Let's go ahead and square root both of those, right, to solve for my radius. And now I have r equals not 625 anymore. Whoops. Square root of 625, I believe, is 25. Right? Hopefully, that's what I planned on. I should have checked this before. Let's see here. 625 raised to the 0.5, 25. Okay, we are good. All right. Just want to double check before I put this out on the internet, and it's wrong, right? You wouldn't want that. So we got 25 inches for my radius. How's that going to help? Well, that's CA here, but I only want this, right? This is the length that I want. This is my X, if you will, right? That's what I want to get. Well, perhaps I could draw a radius in, right? You know, the last time we did that, so why not try it again? So I'm going to go ahead and scribe that nice and straight with my old ruler. So I got a triangle, but what is a triangle really unless it's a right triangle? Oh my goodness. Didn't we say that because this was perpendicular, these two are congruent, it bisects, and it works vice versa? Yes. If a radius bisects a chord, it is then also going to be perpendicular to that chord. We have a right triangle. We have two sides, which means I can hit this thing with some Pythag, right? Now, this is another triple, actually. It's a 7, 24, 25. So this guy right here is 7 inches. But if you did not know that, we would set it up as, let's go a squared plus 24 squared equals 25 squared. And then we'd end up with a squared equals 49 after doing some calculations and whatnot. We'll get a equals 7 after you square root on both sides, okay? So it helps to know some of those triples, right? It helps to know those. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are your four main ones that you'll see actually come up all the way through calculus. I see them in calculus a lot as well, just to keep numbers nice and working with right triangles. So we do that a lot. So knowing those four, helpful. You can double them, triple them, whatever. But that's not what the answer is, right? I wanted CE here. Well, how am I going to get CE? Well, let's see. EA is a portion of CA. And I know all of CA that's a radius, right? Which is 25. So what if I just did 25 minus 7? And 25 minus 7 would be what? 18? So we got 18 inches for my final answer. Nice. That is CE. Cool. We did it. We could have been just asked to find the length of EA, which is 7, right? We could have been that's pretty much about it, you know. Yeah, given the area, they might ask for what's the radius. They might ask for what is EA, other things, right? We could ask for little pieces, parts. With this one, I had to find the radius so I could subtract and get just that segment right there. We could even ask for, like, we could go crazy, man. We could be like, what's this length right here? What's CB? You'd have to Pythag again. That one's not a Pythagorean triple. So we'll leave this one as is, but lots of possibilities within these problems where we have radii that are either perpendicular to or bisect a chord, because then you get the other one. You could set up right triangles. You could do Pythag. We can even throw a trig at you because they're right triangles. No, possibilities are really endless here. It's a lot of fun. All right. Hopefully that helps, and you guys have a great day.